Texas, 68 million years ago. As thunderclouds encompass the prehistoric landscape, a large bird-like creature known as Quetzalcoatlus is seen feasting on the remains of a large dinosaur. At 18 feet tall with a weight of 550 pounds and a wingspan of 40 feet, Quetzalcoatlus is among the largest of the flying creatures to have ever lived. Though this may be a bad time to hold on to such a mighty title. Struck down by bolts of lightning, the giant Azdarchid lies on the floor immobilized, possibly dead. But why does this happen? What generates lightning so frequently during thunderstorms? Hello everyone, Awesome Artavius 101 here, and I hope to answer these questions and more on our today's topic of discussion, lightning. So to start, let's discuss what lightning even is. Lightning is a natural phenomenon that mostly occurs during thunderstorms and is a type of plasma. Plasma is the fourth stage of matter after solid, liquid, and gas. In addition to the free-roaming sporadic movement of atoms in a gaseous state, these atoms are now electrified in a plasma state, which will become useful later on. Other examples of plasma include the sun and the aurora borealis, or the northern lights. So, now that we know what lightning is, we can discuss how it's formed. Inside the clouds that generate lightning, tiny water droplets that have frozen into ice crystals rapidly collide with each other. These collisions cause negatively and positively charged particles, electrons and protons respectively, to be displaced and lost in the cloud. The displaced protons gathered on top of the clouds, and the electrons gather at the bottom of the clouds. The ground at this time is full of protons, and because opposites attract, the protons and electrons rapidly accelerate towards one another through something called a stepped ladder at speeds of around 200 million miles per hour. Now, pretty much anything moving at almost a third the speed of light would generate a lot of energy, and because we're dealing with oppositely charged particles, a surge of electrical currents is bound to occur. Combining these factors is how you end up with the bright streak of plasma that's 5 times hotter than the surface of the sun. This is why taller objects tend to get struck by lightning more often, because the particles want to be able to cover less distance to reach each other and the gap is smaller. Now, the power of lightning is not something to be taken lightly. Lightning strikes are estimated to hit 200,000 people annually, with 10% of cases being fatal. Most deaths are actually from cardiac arrest induced from the electricity of the strike rather than the heat. And those who survive usually have severe burns and permanent scarring, though brain damage and flayed pieces of skin have also known to occur. So, how can you avoid becoming a victim of Zeus's next target practice? Well, there are a few steps you can take if a particularly bad storm is out to ensure your own safety. Avoid using water or electronic devices, as metal and water are great conductors of electricity and may invite lightning towards you. Don't stand near tall structures and do not stand in the middle of an open field. You're actively making yourself vulnerable in those instances. Seek shelter in a secure building or an enclosed vehicle in the event that a building isn't nearby. Convertibles and golf carts are vehicles that you'd want to avoid. Also, pro tip, if your hair starts standing on edge like this, it means you're about to get struck down and you should get out of the area immediately. One of the many elements needed to support life here on Earth is phosphorus. It's needed for the building of DNA and RNA and helps the growth and repair of cells. So how did this essential ingredient come to be on Earth? Well, lightning may have the answer. A 2021 study by Benjamin L. Hess, Sandra Piazzolo, and Jason Harvey suggests that lightning may have helped the production of more active phosphorus on Earth. The basic idea is that unreactive, insoluble phosphorus minerals were trapped in the Earth's surface, unable to support life for a long time. Frequent lightning strikes on the young Earth reduced the amount of inactive phosphorus and provided the materials necessary to allow the more active variants to spread, and eventually help the Earth support life. While the study is recent and therefore is awaiting any form of criticism from the scientific community, it is a fascinating way of showing that while lightning may be deadly, it can also support life under the right conditions. Thank you everybody for watching. Hope you enjoyed this different kind of content, and I'll see you in the next one. Take care.